Welcome to section 5.3. In this section, this is another pretty long section, and you're going to have a lot of information thrown at you here. We're going to be working more with the unit circle this time. However, there is a massive amount of information that has to be memorized in this section. So just giving you a heads up. Make sure that you are studying your unit circle and continuing to work on memorizing it, especially the first quadrant. I will let you know when we get to the new material that you have to memorize. So in this section, we're going to be looking at the right triangle based definitions of the trig functions, and we've got this illustration here. We've got, if we have an angle that's in the standard position with initial side on the x-axis, terminal side passes through this point B. We have the radius here. But now we're going to be looking at these as right triangles. So we're going to use the definitions that involve finding the side opposite a given angle, finding the side adjacent a given angle, or the hypotenuse, etc. So you probably should have seen these before at some point. So we're going to let A represent any acute angle A in standard position, meaning means it's going to be in the first quadrant. Sine, we already know to be defined as y over r, but if we look at our picture, the sine of A, or angle A, is going to be y over r, which we can see as the opposite side over the hypotenuse. So we can say that sine is equal to opposite over hypotenuse. Cosine, and I'm sorry to have to bounce back and forth like this. I'm just going to talk about it, and then but you've got your formulas you can look at as I'm going through this. Cosine of A we know to be x over r, and if we've got this triangle from the standard position, we can think of this as the cosine of A being the side adjacent, x is the side adjacent angle A over our hypotenuse r. So we've got adjacent over hypotenuse defines cosine. Tangent is, we know to be y over x. So if I'm working from angle A, y would be the side opposite angle A, and x will be the sine adjacent angle A. So we can say that sine of A is equal to the opposite over the opposite over the adjacent. So that's how we get the first three definitions. And then the remaining ones we know to be the reciprocals of the ones that we already did. So we know still cosecant is still the reciprocal of sine, secant is still the reciprocal of cosine, and cotangent is still the reciprocal of tangent. It's when you're working with the right triangle based definitions that you can use the little mnemonic device SOHCAHTOA, or you might have another one that you might have learned, but it's SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So however you need to remember that is fine. Alright, let's look at example 1. Find the sine, cosine, and tangent values for angles A and B in the right triangle. So we're doing it for angle. When we do it for angle A, sine A is equal to opposite over hypotenuse. So which side is opposite A? Well, opposite A means you're way over here, so it will be 7. And then our hypotenuse, of course, is the side opposite the right angle. So our hypotenuse is 25. So 7/25. Cosine A would be the side, again it's all in reference to angle A. So which side is adjacent to angle A? Well, it's not going to be the hypotenuse, so it's going to have to be this side, the 24. So we're going to do adjacent over hypotenuse, which is 24 over 25. Tan of angle A is opposite over adjacent. So here's A. Opposite is 7, adjacent is 24, so 7 over 24. All right, and then we know that cosecant is the reciprocal 25/7. Secant is the reciprocal of cosine 25/24. Cotangent is the reciprocal 24/7. So that's all the 6 trig functions for angle A. Now we're going to do the same thing for angle B. And I really wish I had another color, but I've only got blue and purple. So we're going to do the same thing now for angle B. We need to do sine B. So find angle B, that's here. We want opposite over hypotenuse. So opposite angle B would be side 24/25. Cosine angle B is going to be the adjacent side 7 over the hypotenuse 25. Tangent of B is opposite over adjacent, so 24/7. All right, and then we'll do cosecant. We know is the reciprocal of sine, so 25/24. Secant is the reciprocal of cosine, that's 25/7. And cotangent is the reciprocal of tangent, so 7/24. And those are our answers. Now in the problem that we just did, I'd like you to take a look at something. Notice that, let's look at cosine A, and let's look at sine of B. All right, here's cosine of A was 24/25. Sine of B was also 24/25. All right, what about sine of A and cosine of B? Sine of A was 7/25. Cosine of B was 7/25. That happens because if you look down here, we're going to talk about cofunctions, and looking at the discussion at the bottom of the page. We've got a right triangle ABC. All right, the length of the side opposite A is going to be lowercase a. The length of the side opposite angle B is going to be lowercase b, and then lowercase c is our hypotenuse. We know, from our preceding definitions, we know that the sine of A is equal to A over C. Okay, so sine of A here is going to be the opposite over the hypotenuse, A over C. We also know that cosine of B is adjacent over C, so that's A over C as well. It's 2 different ways of saying the same reciprocal. So that means that sine A is equal to cosine of B, and they're both equal to side length A over the hypotenuse. That makes these what we would call cofunctions. Okay, we can say the same thing about tangent. Tangent of angle A. So tangent of angle, go back at look at the example. Tangent of angle A was opposite over adjacent, 7/24, is the same thing as the cotangent of angle B, which was 24/7. Or excuse me, cotangent of angle. Cotangent of, I'm sorry, I said that wrong. Tangent of angle A was opposite over adjacent, 7/24. And cotangent of angle B was also 7/24. That was starting from here, opposite over cotangent of B was adjacent over opposite, so 7/24. So tan of A, tangent of this angle was equal to the cotangent of this angle. Sorry. Tangent of angle A was equal to the cotangent of angle B. So that makes those cofunctions as well. All right, and then it's also true that the secant of angle A is equal to cosecant of angle B, because the side lengths, the ratio of the side lengths will be the same either way. So since in any right triangle, our 2 acute angles add to 90 degrees. So that means that we have cofunction pairs. Sine A equals cosine of 90 minus A. Cosine A equals sine of 90 minus A. then you have the cofunction pair secant A equals cosecant of 90 minus A, and cosecant A equals secant of 90 minus A. Tangent of angle A is equal to the cotangent of 90 degrees minus that angle. And again, this is all because we're working with the right triangles. Cotangent of A is equal to the tangent of 90 minus A. So tangent and cotangent are cofunction pairs. Secant and cosecant are cofunction pairs. Sine and cosine are cofunction pairs. Let's look at example 2. Write each function in terms of its cofunction. So we've got, in part A, we've got cosine of 52 degrees. Well, the cosine is a cofunction pair. Cosine is a cofunction pair with sine. So we would say this is sine, and then we would do 90 minus 52. So it would become sine of, was it 38? Okay, sine of 38 degrees. In part B, tangent 71 degrees would be written as cotangent 90 minus 71 degrees. So that would be cotangent of 90 minus 71 would be 19 degrees. And then for part C, secant of 24, the cotangent pair of secant is cosecant. And it's going to be 90 minus 24. 90 minus 24 would be, I believe, 66. Okay. So cosecant 66 degrees, or cosecant 66 degrees. So the cofunction pairs are not difficult. Just try to remember which ones go together. Okay. All right, this stuff that we're getting ready to talk about is extremely important. We're building up to some very, very important information that you're going to be having to memorize, basically. So we're doing trigonometric function values of special angles. So we're going to look at an equilateral triangle, meaning that all the angles are the same and all the sides have the same length. All the angles are going to be 60 degrees to add up to the 180. For convenience, we're going to let each side have length 2 units. Now, yes, they could all have length 1. They could all three have length 5, but we're going to choose 2 just because it's going to be a little easier for us to work with that way. So with the equilateral triangle, they all have, all the angles are 60 degrees. We're going to basically cut this triangle in half and create two right triangles. The 2 right triangles are going to look like this, here, here, and here. So they've each got a 90-degree angle. They've got the 60-degree angles here, and then the 30-degree angles at the top. And the original side length of 2 is the same for the hypotenuse in the new triangle. And then the bottom, the base, was cut in half, so it's going to have length 1. And then the Pythagorean theorem gives us a height of square root 3. So that's, if you did 1 square plus, I'm going to put in an x here, and then the hypotenuse square. So 1 square plus this height square plus the hypotenuse square. Solving this for x, subtract 1, so x equals plus or minus square root 3. Of course, we don't want a negative length, so our height is square root 3. Okay, so I'm going to keep this here just as a reference, so you won't have this close by to look at. What I'm actually going to do is I'm going to take one of these triangles and blow it up so it's larger, easier to see. Let me draw it where it's easier to look at. So I'm going to take, say, this one here and just make it bigger. So I've got, this is my original side length of 2. My height I found to be square root 3. My base has length 1. And then my angles, this is the original 60-degree angle, this is a 90-degree angle, and up here is a 30-degree angle. So I've got this 30, 60, 90-degree triangle. We're going to go through and find all the trig values out of this whole thing. All right, and what we're finding is very, very important information that we're going to have to remember. All right, so let's see how we get all these values. Try it this way. So we're going to basically, I'm going to just do it here, and then you've got it in your notes you can use as a reference. But I'm going to use this, and I'm going to go through and I'm going to find sine 30 degrees. All right, I know that sine 30, sine, based on my right triangle definition, is opposite over hypotenuse. So that's sine of 30 here is going to be 1 over 2, so 1/2. Cosine of 30, I know, is adjacent over hypotenuse. So cosine of 30 would be square root of 3 over 2. Tan of 30 is going to give me opposite over adjacent. Alright, so find angle 30-degree angle, opposite over adjacent, that's 1 over the square root of 3. And when I rationalize the denominator, I get square root of 3 over 3. Okay, now these values are going to be the same for any triangle that has these angle measures. Now the side lengths can be different, but they're still going to be proportional. So sine of 30 degrees will always be 1/2. Cosine of 30 will always be square root 3 over 2. Tan 30 will always be square root 3 over 3. And if you look at the unit circle, you'll see that. So on your unit circle, just looking at the 30-degree angle right here, you'll see that sine of 30 degrees is the square root 3 over 2, which is what we just got. Cosine of 30 degrees is 1/2. And tan of 30 you would get by doing 1/2, by doing y divided by x. So 1/2 divided by square root 3 over 2 would give you the tangent value that we got, square root 3 over 3. But this is the sine of 30, this is the cosine of 30. It's the x coordinate and the y coordinate of that angle. All right, and we could keep going in your notes. So you'll see that I've included cosecant 30, secant 30, and cotangent of 30 as well. And you know, if you can get sine, cosine, tangent, you can easily get cosecant, secant, and cotangent by doing the reciprocals. So it's the first three. It's the sine, cosine, and tangent of 30 degrees that are the most, really honestly, the most important that you're going to have to remember. And we've got it's on the unit circle, so you got to know it that way. And there is also a table that has the information that you need to know. You don't have it yet, but it's coming up. So let's look at example 3. All right, we're going to use this 30, 60, 90 degree triangle to find the 6 trigonometric function values for a 60-degree angle. So we just did it for 30 degrees. Now we're going to do it for 60 degrees. So we need to do sine 60 degrees. So here's your 60-degree angle. You need to do opposite over hypotenuse. So it's going to be square root of 3 over 2. Let's do cosine of 60 degrees. All right, cosine of 60 is going to be adjacent over hypotenuse. So that's going to be 1/2. Tan 60 is going to be opposite over adjacent. So that's square root of 3 over 1, or just square root 3. All And then we'll keep going. We'll find cosecant 60. We know we'll get that by doing the reciprocal of sine, so 2 over square root 3. And then we rationalize the denominator. That gives us 2 square root 3 over 3. Secant 60 is going to be the reciprocal of cosine, so that's 2. Cotangent 60 is going to be the reciprocal of tangent 1 over square root 3. Rationalize the denominator. It'll be square root 3 over 3. Now, these values that we just found will always be true. So, sine of 60 is always square root 3 over 2. Cosine of 60 is always 1/2. Tan of 60 is always square root 3. Look at your unit circle. Let's look at the unit circle and find sine of 60. Find your 60-degree angle. Here's your 60-degree angle. Sine would be the y-coordinate of this point, so square root 3 over 2. That's sine 60. And cosine is the x-coordinate of that point, 1/2. Okay, now we're going to do a similar situation for a 45 degree, 90 degree triangle. And this time, so we've got our 90-degree angle. These angles are going to be the same. They're both 45 degrees. So that means that these two sides are going to be the same length, and we're going to let them be 1 to keep it as simple as possible. Using the Pythagorean theorem, we find that 1 square plus 1 square equals our hypotenuse square. I'm just going to call it x squared. Solving for x, what do we get? 1 plus 1 equals x squared. 2 equals x squared. So square root of 2 equals x. So our hypotenuse is the square root of 2. So with this, we're going to find all the trig functions for this triangle. And I'm going to do this with you. Even though you've got it in your notes, I still want to go through it with you. So these are the 45-degree angles here and here. So we want to do sine 45. We're going to do cosine 45. We're going to do tan 45. So sine of 45, just pick either one of the 45-degree angles. So let's say I start here. Sine is opposite over hypotenuse. So that's going to be 1 over square root 2. I have to rationalize the denominator. So that would become square root of 2 over 2. Alright, let's find cosine. So go back to my 45-degree angle. Cosine is going to be adjacent over hypotenuse. So 1 over square root 2. So again, square root 2 over 2 when we rationalize. Tangent of 45 from here, opposite over adjacent. So that's going to be 1 over 1 or 1. And then the remaining 3, reciprocal of sine is cosecant 45. So I'm going to take the reciprocal of the one before I rationalized it. If I flip this, I just get square root 2. The reciprocal of cosine is secant. So secant 45 is also square root 2. And cotangent 45 is going to be the reciprocal of 1, which is 1. Okay? Now, these up here, we're going to have to know these. Sine of 45 will always be square root 2 over 2. Cosine 45 will always be square root 2 over 2. Tan 45 will always be 1. There's so many different ways that you can think about this. Let's just look at the tan 45 for a second, okay? So let's say, I'll draw a picture, and I've got a 45-degree angle. So it looks like this. Okay, we said earlier that the slope and the tangent would be the same. So if I've got this line, this 45-degree angle, then it's got, if you remember from algebra, it's got a slope of 1 because it's if it's a 45-degree angle, that just means that every time you go over 1, you go up 1, you go over 1, you go up 1. So this line has slope 1, and the tangent of 45 is also going to be equal to 1. So, let's look at the unit circle. Let's look at the sine 45, cosine 45. All right, find sine 45 on here. Find your 45-degree angle. Sine of 45 would be the y value here. Sorry, the y value, square root 2 over 2. Cosine of 45 degrees is the x value, square root 2 over 2. Okay, and that matches what we have. And then if you do tangent, y over x is going to be this over itself, so that's going to give you 1. Okay, so that was what I had done on page 7 of the notes. At the bottom of page 7 is a table. You might want to use this as a reference for the homework problems in this section in addition to the unit circle. However, this information, the first 3 columns, the sine, cosine, and tangent, absolutely must be memorized. These are your multiplication facts for this course, essentially. If you're not able to immediately tell me that sine of 30 is 1/2 or cosine of 60 is 1/2, if you cannot tell me that just like this, like a multiplication fact, just like you say 7 times 6 is 42, you are not going to be able to pass this course. It is absolutely, absolutely essential. So these values, however you choose to memorize them, you have to do it. So you can go ahead and say to memorize the stuff. And the sooner you do it, the better.